Alrighty, just waiting on YouTube to show me my stream preview. Alright. So we have a black screen. And we're live, everyone. Alrighty. So, welcome back to another stream. So, in the last stream, we started modeling this enclosure for my new NAS. It's built around a mini ITX motherboard. It has a single expansion card slot for a full height expansion card, which will be a riser card between a low profile gigabit 10 gig Ethernet adapter and a breakout that lets me hold more M.2 drives. So in the last stream, we found out that the thought of where to place the drives would not fit inside of a 3U enclosure. So originally I was hoping to be able to do a 2U enclosure for the computer and then a 2U enclosure for the hard drives for a total of 4U. But with this full height card, I can't fit the computer into 2U. The plan was to have a custom riser card, which would knock a couple of cards over 90 degrees, so they'd be laying flat. And we can still thinking about doing that at some point. But all of these parts have just been sitting in my closet for 6 months now, and it's like, okay, I just got to do it. I got to come up with. I got to do a temporary solution, which is probably going to end up becoming a permanent solution, But either way, so we need 3U, and even though we're doing 3U, we still can't fit the hard disk area, which is this blue rectangle, into the 3U. So we're going to leave the hard drives out of this main enclosure component. And what we'll do instead is use this for mounting like Ethernet jack capstone, like patch panel capstones, or my little edge router or something. We'll need to figure out what to do with the space. And so today we're gonna put a bit of a pause on this piece. We're gonna start modeling the hard disk enclosure, which will contain, hopefully in 2U, will contain 6 3.5-inch hard drives. And remember, that's the platter size is 3.5 inches. The physical unit is 4 inches across. So I figured we'd start by looking up a mechanical specification for a 3.5-inch hard drive, or at least some drawings. Which I don't know where the connectors go. And so either way, I'm hoping to fit dimensions. Western Digital is probably a good place to look for hard drives. Hard drive enclosure. Oh, well, that's perfect. All right. Is it WordPress? Oh, everything about mini pizza. Interesting. So, well then. I wonder. Holes in the side go. I don't know. Alright. Interesting. Maybe. Oh, here we go. Maybe this will be a better. Oh, that's an IDE drive. Ooh, that's a quantum fireball. Oh, that's an old drive. Okay. They haven't changed the mounting holes, but that maybe we use a data sheet of a drive that came out, this century. um. Oh, DIY 5 and 3 hard disk racks. Okay, nice. So we'll put a pin in that, and let's actually start by coming up with the layout for this enclosure. So let's start with doing or basically creating the external volume. So we have this parameter spreadsheet that we've been using, and we've already defined what a let's see, what the width of one of these enclosures looks like, the depth of the enclosure, what the ears look like. So let's start actually defining some parameters for the hard. Well, actually, let's depth, height. because the height will be different. So we'll say drive HDD enclosure height will be 2 times 1.75 inches, because that's that'll be HDD enclosure height. We'll paste this over here, because otherwise we're going to reuse the parameters from the enclosure, because this is all going in the same case, right? Anywho, let's create a new part for the HDD enclosure. We're gonna hide these bits. We're gonna do this a little differently than we did the other one. We're going to, okay, we'll part design, add a body. It is a little different. So we're going to start with a sketch on the XY plane instead. And what that'll let us do is we're going to do a centered rectangle, or actually we won't do a rectangle at all. Do a line. Do a horizontal line. We're basically going to create this the geometry of what the top side looks like. And then we're going to create what the geometry of the top side looks like, and then pad the whole thing for the whole height. And then, okay, this is horizontal. Cool. And so we'll define what the width here is. And so that's what enclosure width. Parameters, enclosure width. And this is what the ear width is. Parameters, ear width. Parameters, ear thickness. And then this is going to be enclosure depth. Okay. We've got this relative sketch here. We're going to put this, make these horizontal. And then we'll just define what this bit looks like here. We'll define this as parameters, ear width, minus parameters, enclosure width, divide that by 2. And that gives us the shape of the top of what this insert looks like. And we'll just have to, you know, how do I want to define this? So we'll just define this as, we'll just center it. So we'll just define this as enclosure width. Enclosure width divided by 2. And then parameters, enclosure height. Oh, depth divided by 2. Okay, so we got our layout here. We got what our overall shape looks like. So we'll just pad this out to the height. I'm going to pad this out to parameters, enclosure, dry, or what the heck did I call this? I'm sorry. HDD enclosure height. HDD enclosure height. Okay, cool. And then we go back to this. Yes, and then we have what the whole insert looks like. And then so we got what the whole insert looks like. And what we're going to do now is we're going to start basically cutting out from the front, because the hard drives are going to take up most of this front space. So the width of this inner part here, you know, we talked about, it's 220 millimeters, which is I think it's just under 8.5, 8.75 inches. Yeah, so we said 220. So we're basically giving ourselves, you know, a millimeter on each side, right? which we, maybe we might not necessarily want to do, but I think this desk pie, what is this? Can't remember. This is what a 10-inch rack specification is here. Yeah, so 222.25. So we're giving ourselves like a millimeter on each side, which, just for the sake of printing tolerances, we like, although we might end up taking away from... We might end up taking this little bit of margin we have here just to print it just a little bit thicker, just to add some more strength to the walls. But that's we'll worry about that in the future. So now we need to actually figure out how large these discs are, like the face of them. So let's see here. So obviously, platter's 3.5 inches. The case is 4 inches wide. The depth is what does it say here? The depth of the this is doesn't have all the dimensions. Why? Yeah, we don't want to look at the quantum fireball because again we want to look at, even though they haven't changed the mounting holes on these things in 30, 40 plus years, we do want to use a disc from this century. So, oh, here's a dimensions table. Another bad request to Western Digital. Okay. That's a 2.5 inch drive. You'd think that this would be really easy to find. Barracuda, they don't even give mechanical dimensions in here. I mean, why would they? They don't have to. Mechanical dimensions. We'll just say dimensions. Dimensions. I could spell, Again, that's a bad request. Okay. Height 1 inch. Actually 1 inch. My HDDs are all 4. Yeah. Back to Google Images. Fine. Do we have to look at the quantum fireball specification? They're 4 inches wide, 1 inch tall, which the other thing said 5.75 inches long. I don't know if they've changed the. They probably haven't changed the spec. Realistically, they probably haven't changed the spec. Yeah, like here's an icy dock, type thing. 4 inches, 1 inch is 5.7. Yeah, okay. So this quantum. Funny that the quantum fireball here is the most public, example of the sizes of these drives. This quantum fireball came out in the 90s, I think. Either way, whatever. We'll work on that. We'll work with that. So we have 220 millimeters wide. So now we have to figure out exactly how wide we want to have the hull. So we're going to talk about we can reuse this number, the tray width from before, because this basically is the inside volume minus the size of the walls. So if we do, so obviously we want to subtract the size of the walls from the volume that we have to work in. So we have to fit 2 drives side by. We're going to do, because the drives are 4 inches wide, we have an 8.75 inch wide hole. In the rack, we can fit 2 drives side by side. So we're going to do 2 wide, 3 tall. So it's going to be 8 inches wide of drives plus whatever margin I need to have between them, and then 3 inches tall plus whatever margin I need it from them. So what we'll do is we'll just assume that we're going to use all of the available space. So we have inside our we'll basically have a grid. We have this grid of 2 wide, 3 tall. So we need to, inside of our tray width here, how much internal volume we have inside of the enclosure, we need to figure out, how much of that do we want to be the wall at the center, for 1, vertical support, and 2, also for just a partition between the drives, because we also have to come up with a way of holding the drives inside the enclosure, which will just make little rubberized feet that go on it, little rubberized ears that go on, that'll hang on to something inside the hole. So the disc is 4 inches wide. So if we subtract, 101.6 millimeter. So if we subtract, we'll just say 102 millimeter, just to make our lives easier. So we'll say HDD width, And that's going to be, 102 millimeters. Again, just to make our lives easier. 102 millimeter. And then so we have essentially central wall. Well, okay, so how much space do we need? So we have, so just so we can start doing some simple like math here. So we have 214 millimeters minus, 2 times 102 millimeters. So that gives us 10 millimeters of extra space to work with. And that's just any amount of space to work with, right? So not only is it just 10 millimeters, it's 10 millimeters of stuff that isn't the drives. So we also have to include in here, how much width do we want the little legs that we're mounting onto the drives to be? Because we gotta, if you think about one of these drives, we need little things on them so that the drives have something to sit on, and we don't want to make them too tiny, otherwise you can't, it won't fit. But we need to decide how much we're going to give it, and we have to multiply that by 4 because we have 2 sides of each drive times 2 drives, so that's 4. So if we were to say we were only going to use 2 millimeters of space on each side of the drive, that's still, that loses a 2 millimeter vertical column, which we're gonna have to deal with. So we might end up printing this out and find out that it's too weak, but that's fine. Also, since I see that I have 3 people watching right now, if you have any questions and you want to stop me, please. I do try to check the chat as much as I can. If I'm rambling, I might not see it, but I do keep my eye on it. So if you have any questions and you want to ask me something, just go ahead and put it in there. Please feel free. So. So 10 millimeters to work with. So we're gonna this HDD, and just to give a visual reference here. Let me find, what did I do with my calipers? This really isn't a visual reference because you don't have anything. It's don't really have anything to compare this to. But think about that Zip Frank video where it's like, in order to give you a sense of scale of the II, I put an II next to a slightly smaller II. So I just want to show you what does 2 millimeters look like. Because it's really not much. It's that much. I have relatively large fingers, but that's it compared to my finger. It's a tiny amount. If you're making something out of metal, that's just fine. If you're making something out of plastic, well, not as much, but it's okay. So we've got this. So HDD ear width. We'll just say mount width. We're gonna give ourselves 2 millimeters here. Call this mount width. And then that gives us HDD spacing. We'll do the HDD enclosure column width. This will be the central column between the enclosure. Will be equal to enclosure tray width minus 2 times HDD width minus 4 times HDD mount width, and that's going to give us 2 millimeters. Yep, there we go. Okay, so let's start modeling. So actually, we need the vertical one too. So we're gonna just cut this column here. Give that a alias. Cut this column. Insert one above. Place that there. Take the little alias. Put that over here. Okay, so column width, HD mount width. So we need, so HDD height. So we'll just give ourselves a row here. HDD height. That's going to be 1 inch, which 2.54. So 26 millimeter, just to. Okay. And so now we have, we're going to have, well, we don't have a tray height, but we do need to make space. So what we'll do is enclosure. We'll say we give ourselves a tray depth. We'll give ourselves a tray height because what's this number? Oh yeah, minus the bracket thing. I see. Enclosure column width, enclosure height. We're going to give ourselves HDD enclosure tray height, and that's going to be equal to HDD enclosure height minus 2 times, we called it enclosure thickness. Cool. Give this an alias to reference. And then so we got this reference, so enclosure column width, tray height. And that'll give us all right, so now we gotta, so this is the, the amount of vertical volume that we have to work with on the face of the enclosure. So we need, so just as some quick maths here. If we were to say we got 26 millimeters times 3, 26 millimeters times 3. So 78, 78 of these 83 millimeters are going to be used. So we've got, we don't have a lot. We don't have a lot of room here. So 82.9 millimeter. So maybe we cut the margins here a little closer. Maybe we do just call this equals 1 inch. We might need those 0.6 millimeters. So if we've got what is it, 82.9 minus 3 times 25.4, we got 9.7 millimeters to work with. So, oh no, I got that wrong. It's 25.4, 6.7 millimeters to work with, in fact. So we can give each. We don't actually have to put any kind of. What do I say? We don't have to put any kind of vertical bracketing between these. We can just have them free hanging. I mean, obviously crossbars are structurally helpful, but if we can't, what do you call it? Sorry. If we can't fit them, we can't fit them. So, and we do need some kind of air gap. So in the 6.7 millimeter, the 6.7 millimeter, we only would technically need 2 crossbars. So if we were to say these were also 2 millimeters, that would give us 4.7, and 4.7 divided by 3, it would only give us about 1.6 millimeters of air gap around the drive, which is not a whole heck of a lot, let's be honest. And I think I'd rather not have these cross elements, although I mean they would be useful strength-wise. And actually, sorry, that would be 6.7 minus 4, because it's 2 millimeters thick times 2, right? So we only got 2.7, and 2.7 divided by 3 is just a little less than a millimeter of space for air to slip around the drive. And these are NAS drives. They don't get super warm, but longevity from we need to cool them in order for them to last a while. So I think it's better probably just to not put the cross elements in. But based on the flexibility of whatever material we use, it's we don't want them falling out either. So, I mean, although plastic's cheap, so we can try cross elements, and then if that ends up just being, bad, then whatever. But so let's see here. So yeah, we'll start by Do I want to start with him? Or, yeah, so we'll start with him. So HDD, enclosure. So realistically, what we're trying to say here is, what are the size of the holes? So we're saying that they're basically the size of the drives. So we don't actually necessarily need the column width. We just need to HD width, HD mount width, HDD mount height. Well, realistically, what we're going to define is we're going to define the hole that the drive sits in, rather than trying to figure out what these columns are. So we're going to say HDD cutout width, and that's going to equal the HDD width time plus 2 times HDD mount width. And then that there. I'm going to say HDD cutout height, and that is going to equal HDD height plus HDD mount width. I'll just... Perfect. Okay. And so what we're going to do, we're going to say also we need a HDD enclosure front depth. That's going to be the depth we're going to cut into the front of it, just to give us a nice place to put to see the drives. And we're just going to say that that's going to be just like the rest of everything. We're just going to call it 3 millimeters for now. If we want to change it, we want to change it, but it's fine. And then okie doke. So now we're going to come in here. We're going to draw a sketch on the front. And actually, before we really start doing this, what we're going to do is we're going to align it with our view of the enclosure here, just so we can visually see what all this looks like relative to each other. Rear here. Yeah, okay. Transform, placement, position. So we got a 91, 94. Line these up, 94.8, 7, 6, and then 88.9. And those are aligned. Okay, cool. This looks up, and then we got to fix the depth. So we're going to look at the left side. We're going to take the transform of this. And then we'll just... Yeah. I'll just do it this way rather than trying to come up with a better way, which is fine for now. All right, so in the rack, we're going to stack the hard. We're going to put the hard drives below the computer. And then, all right, so we're just going to rehide the enclosure here. All right, so take the front panel, draw a sketch. Then we're going to do a centered rectangle here. The distance from here is parameters, enclosure thickness, distance for external geometry. The distance from here to here is parameters thickness. And then the width is going to be parameters tray width divided by 2. Right, cool. And that gives us our front panel. And then what we're going to do is we're going to say we're going to make a pocket. And then we're going to say that is parameters dot front enclosure front depth. Okay, cool. This is a nice little cutout, just this for aesthetics, right? And all right, I like that. Cool. What does it look like if we give it a fairing or a flan? What the heck is that called? Chamfer? Yeah. Oh, neat. All right, cool. Might need a chamfer it just so we can print it, because ideally we'll print it without supports. Will be this nice looking place to put our discs, right? Yeah, it'll look nice. Okay, cool. That hide the enclosure. All right, so we're going to start cutting out the holes for the drives. So we're going to start by placing a sketch here on the front. We're going to import all of this external geometry. Inside. Realistically, we don't. Yeah, either way. Show. We're going to say, as I said before, we're going to need 6 rectangles for the holes for each drive. This is if we're deciding to have cross elements. Okay. And then we're going to say the distance from... Actually, these are all going to be coincident. 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 These are going to be coincident. And coincident. And these are going to be coincident. These are going to be coincident. And these will be coincident. Now, trying to get the point. Yes. Coincident and coincident. These will be horizontal of each other. These will be horizontal of each other. These will be horizontal of each other. These will be vertical of each other. These will be vertical of each other. These will be vertical, and these will be vertical. Cool. We've got all of this spacing and stuff in here. All right, so now we can say that this will be HDD hole size, cutout height, okay, will be params HDD cutout height, and the spacing on these will be, well, this column. Width. divided by 2. Is it centered? Alrighty. We've got our drive cutouts. So what we're going to do now is we're going to close that. We're going to make pockets. And we'll say that these are parameters. HDD depth, or depth something. Depth. I don't actually think I've defined the depth yet, actually. HDD depth. Nope, we hadn't done that yet. Quantum fireball. So they are, 100 and we'll just say so 146. What did we say in that other one that we found here? 5.77 inches for this. 5.77 inches. 146.56. That was the old fireball. Almost there, yeah. Sure, why not? Alright, so HDD depth. We're going to copy that. Set this as the alias. Alrighty. Alrighty. Set that as the alias. Right, and then we're going to come in here, going to take our sketch. We're going to do a pocket. And then we're going to do HDD depth. Alright, okay. There we go. Now we have our little shelves that our hard drives will sit on. Nice. Looks kind of cool. Getting the enclosure back, yeah. Have our nice little drive caddies. Perfect. Alright, so now what we need to do is define, because now we need to define that, like, effectively little hooks on top that catch the drive rails, essentially. So we've defined this cutout as a little bit more than the HDD height, right? So we need to figure out what the offset of the hull pattern. So we're going to assume that it hasn't changed since these fireballs. So supposedly, it's 0.25 inches up. That's the center line of these drive mounts here. Let's see. Front depth. So yeah, basically, what we need to do, what we're trying to do now is we've got, so we'll have the mounting holes for these little, we'll have to do the little mounting hole, or sorry, keep repeating myself over and over again, sorry. So yeah, we have to, we also have to decide how thick these are going to be, or how tall is this mount rail going to be too. So it's 0.25 inches up, so it's 1/4 of an inch up, it's mounted, I don't even know what the, what's hard drive screw size? Hard drive screw size. Typically use number 632, so we need to look at number 632 screw dimensions. Those are the red diameter major. Nominal thread. So we need basically a 4mm hole again. Okay. So if it's 4mm hole, we always want to give ourselves. So we'll make 4mm hole. So we'll try to make. We'll say that they're going to be 8mm tall. We're going to say that the little drive hooks are going to, or the little things that bolt onto the sides of the drives to hold it will be 8mm tall. So so we'll insert a row here. Insert one row above. HDD mount height. This should honestly be called HDD rail, but whatever. We're gonna say 8mm. Because it's going to be 4mm hole, and there'll be 2mm of material on each side. So, yes. So millimeters tall. And just to be double, so, you know, half of that's 4, and if the center line of the thing is times 25.4mm per inch, so that's going to be 6.35mm up. So, HDD mount... HDD hole offset, call that 0.25 inches, alias, all right, cool. So, oops, the enclosure again, yup, and then what we'll do is, yeah, we have our little rails. So if we've got 6.35, we're gonna have 4mm offset. So it will start the rail on the ground because it's only gonna be 2.35 tall, right? Whole offset minus, you know, half the height. So that's 2.35mm until the top. Yeah, okay. Perfect. Okay, so that means that we need to draw a sketch on this face. Or, yeah, I mean, it's easier to do it this way, because the other way that we could do this would be to have defined in the cutout, you know, not to cut those regions, but you know, rectangles are easy to deal with, right? So, so we'll just define at that face, we'll just do a sketch. Oh. We'll do a sketch on that face. And we're going to do a bunch of external geometry imports. We're going to import that point, import that point, import that point. Okay, well let's just start this. Let's just import the walls. Experiment up here first. All right. So we're going to put a rectangle starting on that point to here. Starting on that point to here. Horizontal of each other. Do the right. So yeah, we're gonna have to do the rail is going to be the HDD hole or cutout width minus HDD hole, no, HDD mount, no, HDD width, 4mm, obviously. Divided by 2. Everything's 2mm. So let's make sure cutout width, HDD mount height, rail width. So just equal. Okay. Yeah, rather than do that, it's parameters, rail, HDD. Oh, did I forget to? I did forget to tag it. Alias. Nice. As parts. Rams, HDD, rail, width. Cool. Oops. We'll just rams, HDD, rail, width. Cool. Awesome. And then the height will be, well, realistically, it's just going to be, you know, the distance here from parameters, rail, they call it. It's going to be the whole offset. Whole offset minus params mount height divided by 2. Okay, so we've defined what that looks like. We need to do the ones above it too, right? And so we'll need to print, put that there too. And that will be vertical. Vertical. Ugh. Alright, hold on. Move that out of the way. Cool. All right. There we go. Just to see what that looks like, we're going to say close. We're going to do a padding on that. Reversed pad, and that is going to be cut out, or depth. Okay. So yeah, and those will be the little things that hold the rails. And then so this air gap that we have around the sides of the drive will be essentially the only place the airflow can move. Which is fine. Yeah, now we need to go define this for the other 6, the other 5 bits. Yeah, So I'm kind of curious how, there's not going to be a ton of airflow, but that's fine. That's fine generally. Oh, these overhangs here, printing at an angle is going to be fun. Might just end up having to print face down. Oh, it's going to love that. Okay. Realistically, we would want to print at an angle, but, you know, if we can't, we can't. Oop, what's this? I got an email that I need to look at. Okay. Okie doke. All right, so let's bring in the other external geometry we're going to need. Doop, doop. Okay. Okay. Make these vertical. These vertical. These vertical. These vertical. These vertical. These vertical. Oh, right. I don't even have the ones up here yet. Okay. All right. Vertical. 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 Okay. Vertical. 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 All right. That goes there. Let's do horizontal. 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 So I'm being quiet. I'm just running through, doing all these little constraints, settings that I need to do. Horizontal. 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 which ones of these have done so far. So many of them. Oh, it's done. Hold on. Okay. Horizontal. 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 Okie doke. We're gonna copy this. And a parameter finally. This parameter. Nice. Okay. Right, and so then what we have to do is we have to come over here, you gotta copy this. Okay. Do that. Do that. And then we can copy this. Do our distance from here to here. All right, and that fixes all of them because we've defined all the constraints. So, cool. Yeah, there we are. Yeah, okay. So, we've got our little drive mount rails all right here. Cool. So the drives will go in, and they run into the back because there's no cutouts for any of the stuff on them yet. Okay. So now... look at our closure on top, eh? It look like a real filey server looking thing, huh? Or a switch on top of it, and it's going to be all sorts of full. Okay, cool. Perfect. I just reply to one thing real quick. Okay. Perfect. So we've got this. Drink here. All righty. Okay, so now we need to work on the cutouts for where the interface goes on the drive. So from this depiction, if we trust it, is... I'm really hoping to consider this the center of the drive too. Yeah, it's not like they actually copy into the any of that. So lovely. So what we're going to do now is we now need to remove. So we need to leave these as stoppers and then keep cutting out of the bay here. Okay, hold on. Oh, hold on. Let me real quick here. Need to check something. All right, sorry, just fix that real quick. Okay, cool. So yeah, so we keep removing stuff from this volume, and all we really need to do is make sure that we put little stoppers behind this. Basically, just keep some stoppers behind where the disc inserts go, and that will leave us with what we need for to hold the drives in, but access the backs of them. There we go. So we're going to now start cutting in from the top, and I want to import this geometry right here. So we're going to do another sketch, and that's going to be a cut into the top. So we're going to sketch here. And I'm going to import the geometry. Oh, come on. Come on, come on. Import external geometry, GX. There we go. Import that line. There we go. That will give us essentially the depth that the drives start at. We're going to define a rectangle. I'm going to do a centered rectangle here. We want to cut out at the... This is going to be the parameters, hard... it's just our HDD depth. Oh wow, we really don't have much room back there, do we? So yeah, and then... I'll make these coincident. Import that one, and then make the distance here. The thickness. And the distance from here to here is also going to be enclosure thickness. All right. So we're going to do a pocket. And that is going to be parameters, HDD enclosure height, minus 2 times, or minus parameters enclosure thickness, because we don't want to cut into the bottom. Okay, cool. Oh, no, crud. Pocket. Parameters. Enclosure thickness. No, enclosure... HDD enclosure height minus parameters enclosure thickness. Okay, cool. Yay, there we go. Now we can see the inside of our drive bay. And at some point, what I'm going to want to do is build a backplane for this, but that's not today. So what we're going to do is we're going to make sure that we don't forget to put our little stoppers on the back here. And, you know, I mean, we could avoid cutting that far in, but I do want to make sure that we have the proper, what do you call it? Proper airflow. There we go. So we're going to do a sketch on this face. And we're going to import all this external geometry right here. Doop, doop, doop. Oh, jeez. Just to explore. It's a rectangle. That's going to be dunk, dunk. Ported there. So it looks like we don't need that one either. So we're just going to do a rectangle from here to here. Cool. And yeah, well, they want them to be behind the drives directly. So then we'll just do a pad. A pad. These will just be, you know. Whatever, you know, we don't need to do any maths. 2 millimeters. Alright. Yeah, just like the rest of everything in here, right? You know? We'll do a sketch and go import all the geometry that we need for the other stuff. Doop, doop. Doop, 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 doop. Doop, doop. Nope, not that one. Doop, doop. Alright, cool. Nope, missed these ones. Okay, then we got that to that, that to that, that to that. Alrighty. There we go. We've got some of that. I don't know. Maybe what we ought to have done was drag it to the, you know, basically kind of let it anchor to the base here, but, well, we'll see how easy that'll be to change if we want to do that. I don't know, mate. I don't know. Actually, you know what? Yeah, if we undo all of these imports, you know. Oh, lovely. If we undo all of these imports, delete, 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 do delete, 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 delete. Okay, we're going to change which ones we're importing. We're going to import the top, per usual. We're going to do that, and we'll draw from there to there. Do top, bottom, top, bottom. Oh wow, that one's a tad long. Oh well, do that. We'll do that. We'll do that. And we'll do that. And we'll do that. And we'll experiment here with that kind of import. So it's got to recompute the geometry. There we go. So we'll do that there to there, there to there, there to there, there to there. That works. There to... honestly. There. I'll give that to me. There we go. Dang it. Because we've got a couple of points here, we'll do... So we can import the point. Hey, there we go. Perfect. Do rectangle, we'll do that to that. Oh, I missed. Doop, doop, coincident. Doop, coincident. There we go. Yeah, you know what? I do like that. I like that a lot. So rather than importing... Yeah, you know what? I do like that a lot. So yeah, delete, 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 delete. I do like that a lot. Although there's not really any way, we don't get a point here. We only get... This could have been cool. Well, we'll have to make it coincident. We don't have to worry about it. Okay. Yeah. Okay, cool. So, we'll do that, and then we'll do that. Because I can't click on these points correctly. That's coincident. There we go. That's how we do it. So we click on a point here, put it on this axis, we put it on here, so it's coincident, stuck there. Make these 2 points coincident. There we go. Cool. So we close that. Yeah, there we go. That's how our little end bits will go. Because we want to keep these holes here just because of areas instead of lines when extruding in FreeCAD. There was a Starship launch today? Oh, how did that go? I figured... Oh, hey. And at 6:30 p.m. Central. How did I not hear this from Scott Manley? I don't know. Okay. Either way, how do we select success and manage to deploy dummy satellites? Oh, perfect. Okay. I needed a victory. All right. So how to select an area to extrude instead of lines? That's a good question. There. So I think, let's see. So if you do, like, let's say this surface. I think if you select like a random piece of surface, like if you go into the part toolbox and you click it, rather than doing a sketch, I think if you just select a random face, if you could like click pad and it'll just extrude. Or it'll pad. So like, for instance, if I were to select this face, which is a complex face, and I just click pad, the whole thing pops out. So I think you just click on a surface and then use the pad tool. Okay. Oh, from a sketch. Okay. Okay, how do you select? Oh. Use the. Oh, that's a good question. Okay, no, sorry, I know what you mean. Because yeah, if you were to say import external geometry and then you click on a face. Oh wait, that did something. Uh. Okay, so there's another thing you can do. Maybe this might be what you want. If you have a surface that you want to draw on, or something like that, like some complex geometry. If you were to say had a couple of points, like let's say I want to edit something along like this plane. So if I select a couple of points like this, like let's say this corner, that corner, just say that corner, not a line, sorry. Let's just say I want that, hold on, that point. I didn't select it. I tried. There we go. So we got a point. Got a point. We got a point. You can do this thing called like create a datum plane. It creates this like plane that you can work off of. And then you can create, you know, that plane, and then you can create like a sketch off of that. And now you're working on that like geometry, or like resets the axis. Selecting areas of lines. I'm not sure if you can just randomly select a face in the skit. Like for import external geometry, I'm not sure. I've never tried to. Usually, my workflow is that I select a face to work on, and then and then draw a sketch on a face, and then do something with it. I don't think I've ever tried to import an external face before. We do tool macro. Let's see, or what is it? It's the external geometry. I don't. Yeah, sketcher. We got our toolbox here. Create external geometry. Create an edge linked to an external. Okay, so that tool I was using anyway can't select faces anyway. Copy the geometry of another sketch. I'm gonna go with I just don't know. But yeah, let's try. Let's at least finish this bit here. Let me make it coincident. Press C for coincident. There we go. Yeah, that's fair. Yeah, it's okay. Yeah, so if I want to extrude part of a sketch, I have a mouse over the area to extrude. Oh, okay. Yeah, it might not be a feature in FreeCAD. You ask them for a feature, they're just going to say patches welcome. Yeah, okay, so we got these little end bits to hold the end of our hard drive mounts in. All right, so considering, okay. So considering we want to put the NAS enclosure on top of this thing, what we'll do is, also would like to reuse this if I can, but I think what we can do is we'll put all like M4 bolts. So okie doke. Okay, so next we'll do. What are we gonna do next? We'll do. So one thought I had, in order to route the cables, because since this isn't like a proper DAS or anything or direct-to-touch storage, what I'm gonna do is I'm gonna cut a hole in the bottom of the actual motherboard enclosure, and that'll let me pass cables from it into the hard drive. We'll kind of just consider the hard drive enclosure to be just like a logical extension of the motherboard enclosure, and then we'll put the Ethernet switch and maybe some network capstone stuff up here. There's just not a lot of space left. At some point, I would like to do a, kind of a back plane, but not today. But I would like to reuse this enclosure because, I mean, realistically, at the end of the day, it's still only going to be, $10 of plastic to print it. Who cares if I need to redo it? All right. So our hard drives will stay in now. I kind of just want to print a. So if we were to print it at an angle like this, we're going to need. Yes, need supports for like everything. Okay. Okay. Okie doke. So I guess what we'll do is we'll start working on the. Do like a little cross beam here, just to like keep the. I mean, I don't even at that depth. I don't know if it's even important that we have some kind of cross beam. We'll put like a cross member here. We'll route the cables up through here. Okay, yeah. We'll do. Again, we'll just do a sketch on this face. We'll import this column. We'll import this column. We'll import that shape too. So what we'll do, draw this. So here. Put these 2 points coincident with each other to lock the height there. We'll do that. We're going to do a padding of like 10 millimeters or something. And we're going to do a reverse pad. We'll do this like 10 millimeters, yeah. That'll give us just some rigidity there. And another thing, now we need to put in the bits that let me call it, yeah, now we need to put in the parts that let me actually anchor this to like some kind of back face to hold it on, like rack ears to hold it on. So what we'll do is put that's what we're gonna do. We'll do one last. We're gonna do one last drawing on the back face here. Another sketch. We're going to import that column, that corner, that column, this right here. Okay, so we got the 4 corners. And then what we're going to do, we're going to define essentially half of a square here. Because we want an M4 bolt, that's going to be, what is a, let's see. So you don't see what my Amazon account is. Amazon is an M4 threaded insert look like? What are the dimensions of these things? I don't know if I bought any M4. I think I did. What are the dimensions on this? They're 6 millimeters by 6 millimeters. Okay. Yeah, 6 millimeter by 6 millimeter hole. Okay. So we'll do, because this is always going to be the center, we'll do 6 millimeter. 6. 6. We're going to do this as a horizontal. That's vertical. Not to worry. I missed the coincident points again. Yes. We're going to do line. Do that. Do that. And do that. Cool. This will be 6 millimeters. Horizontal. These will be horizontal. Oh, I over constrained something. Not happy at me. There we go. Okay. And vertical. Cool. We've constrained all of that. Nice. Yeah, so what we're just doing right now is putting in some mounting points that we can screw the back face of the enclosure onto, essentially. I'm pretty sure that the back of a hard drive, if I remember, the connectors are on. Yeah, are on the, maybe on the left-hand side from our perspective. Interesting. Okay. So yeah, so now what we're gonna do is a... Oh, hold on, I did this wrong. Nope, 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 these need to be double. 12. As these are the corners. 12. Okay, 12. Would have been nice if I parameterized that, and then I could have done whatever I want. Okay. So, that's what we want to do. I want to do a 45-degree arc, essentially. It's going to be horizontal. It's going to be vertical. It's going to be horizontal. It's going to be vertical. And it's just, what angle do I want this to be? I'm going to say 6 millimeters. Because that is the radius of the whole, well, the diameter of the whole 6, so we'll do a radius of that, so it'll be double. And then that'll let us do this, and that'll let us do this. Then we can put a hole in the center, about 6 millimeters. Yeah, and that'll let us put in the big threaded inserts. And I wish, yeah, cool. Come down here, do the same thing. An arc. Doop, 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 and just make sure we get some arcs down. Doop, doop, doop. Doop, doop, doop. Horizontal. Vertical. Sorry. Vertical. Horizontal. Vertical. Horizontal. Vertical. A radius of 6. Oop. 6. vertical, vertical, horizontal, horizontal, radius of 6. Connect there, connect there, connect there, connect there. Connect there, connect there, connect there, connect there. Cool. 6. Oop, oh, broke something. Oop. Back. 6. And 6. Okay, cool. So, and we're going to create a pad, do a reverse pad. And that we'll just do 20 millimeters. Cool. And that gives us pretty much how, it's kind of ugly. Gives us pretty much how that will mount. And we're not going to use bolts. We're going to sink some threaded inserts into maybe even both sides. I can't get my iron in there, so one side anyway. Yeah, we only have to make them 10 millimeters if we're doing that. Realistically. Okay, because we only need 6 mil deep to put in the big inserts, and that'll hold the back on. Yeah, okay, cool. So we've got those. Let's see if my... Okay. So yeah, let's cut the holes in the front for the... Yeah, so let's cut the... Sorry. Let's cut the holes in the front for the rack mounts. So if we recall, we can do a sketch on the face. We'll do a big sketch. We're going to define... There's 6 holes on each side, essentially. 6 holes. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. We go to our rack guide here. Already... we can delete those 2 things because we don't... Okay. When we got all of these, you know what, I think we figured we already defined the hole size, hole parameters, hole diameter. Yeah, there we go. Cool. Nice. Hey. Cool. And these are all vertical. Vertical. All right. And so the spacing that we're looking for is 0.25 off the bottom is going to be 0.25 inches. And the space here is going to be 0.625 inches, 625 inches. There we go. And then it's 0.5 to the next set. And then it's inches. So 0.625 inches. Cool. Okay, so I believe clear. Equal constraint. Can I... Okay, you know what? Let's try that on this side if I can remember. You know, you're perfectly right that there's probably an equals constraint that is the best thing to use right here. We'll just experiment with that. Okay, so delete that one. I think you're right. I think there's some kind of constraint that lets me set. I have not used equals. Constraint block, constraint symmetric. Equality between two lines, or circles or arcs. Maybe that one? Nope. Two or more compatible edges. Oh, I understand. You're probably right about that. Let's do that. Real quick. Doop, 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 doop. Equals. Nice. And if we define the radius of 1, they should all be the whole size, I presume. Ah, thank you. That is a lot cleaner. Oh, no, not coincident. Okay, hold on. Okay. Okie doke. These are all vertical of each other. Not probably going to be able to constrain many things vertical, I would hope. Yes, okay. All vertical. We can define the space. These are all going to be horizontal. And these will be horizontal. Okay. And then inset from the... No. Oops. Import the edge, import the edge. And then... Yeah, it's 0.25 in from that, right? As well, I believe. Yeah, 0.62... well, it's going to be 0.625 divided by 2, I presume. That's the rail width. Sorry. The hole-to-hole spacing is... I made the whole thing 10 wide, so... Then, yeah, it's going to be 0. It's going to be 0.375 inches. Cool. Awesome. And now we can't... Why is it so dark? Oh. Messed up my materials. Sketch. We're going to make pockets. Could be... The pocket should be... the ear thickness. Perfect. Nice. All right. Cool. So now we have our hard drive enclosure, more or less. And we should probably create, if we create the same hole, on the bottom of here, we'll have a place to route all of our cables. So let's go ahead and do that. You know, actually, before we do that, I'm kind of curious. We're starting to get close to printability, so let's... what else is needed? What else do I need in here to actually print this? I think this is actually done. No, this is for a 10. This is called a mini rack, or it's not called a mini rack. It's called a, there are two. There are a lot of rack standards. The primary one for servers is called the 19-inch rack, which, again, 19 inches wide on the front. This is called a what I got is called a 10-inch rack, and it gets 10 inches opening in the front. And historically, these have been used for telecom equipment. So, you know, things like phone switchboards and things like, or phone, like electronic hardware for phone switching. They're not usually used for data center or like computing equipment. But there's nothing that prevents you from doing that. So, they've become kind of popular. So this is like a 10-inch rack. They've become kind of popular in the home labbing world because people like to film with like Raspberry Pis. So here's an example. So, do I really need a whole U for a jet KVM? Okay, either way, I'll figure it out. So, yeah, and here's kind of an example of like a 2U server rack, right? Or a 2U enclosure right here. So this, and everybody has the jet KVM, and that's the one I bought too. Yeah, so that's the thought. This is what I'm trying to do. So I bought one of these. So yeah, so it's not a full like server rack, and then there's now an even bigger one called the OCPV3 rack, which I think is even wider, if not come on, somebody give me a visual of an OCPV3 server. Yeah, they're even bigger, larger than your average 19-inch rack. They're also a lot deeper, but this is a rack standard that Facebook came up with, but it's an open consortium of things. But these, we got that. Where was I? Mini rack, right. I just need mechanical sizes. There we go. Okay. So I think this is actually all we need for the hard drive enclosure. We might want to. I might want to drill some holes in the side here to mount like a backplane kind of thing in the future, but I don't know. If I have to reprint it, I have to reprint it. And I'll just say that. Okay, you know, I'll buy it. Let's just drill some holes in the side here to give us some expansion room in the future, per se. Yeah, so what we'll do a sketch on this side. Just import that. I don't need to import the edge. I'll do that. I'll put the hole here. We'll say there's an M3 hole, so that would be 3.2 millimeters for an M3. 3.2 millimeters, and then we'll do a distance from. We'll import the external geometry for the back of the discs, and the idea will be that these are vertical, and they will have a fixed distance from this. We'll say 10 millimeter for now, and they will have they'll be inset a certain amount from. Yeah, I mean mine's pretty messy too right now. Like I had a fractal node 3 something. Oh, call it 20 millimeter. I got a what is it called? It's a fractal node 304, 302. Oh, it's a 304. Yeah. So I have one of these, and it has support for 6 hard drives in these cages. If it shows me the inside, yeah. So there are these. Each of these little cages holds 2 drives, and so all of my home lab is. You know, I agree with you. I agree with you, Daniel. There. So, where is? No. Okay. So, what do you? Right. Almost done for. Yeah. Goddamn. Sorry. Yeah. You can fit 2 drives into each of these. There's 6 of them, but the only problem is if you fill all 6 drive bays, you can't fit a full-size expansion card into it. You can do, you have to take out the leftmost cage, which means you only have 4 drives, which means there's far better case options if you were only going for 4 drives. So either way, I got this, and then on top of it is a switch, and then I have all my network gear is just piled on top of each other. There's cables running everywhere. It's horrible. As you said, it's real messy. At least it fits under my entertainment cabinet, so I don't have to look at it. But no 2.2. I think the 804 is the big one. Yeah, this is like the micro ATX enclosure, and I think they got a whole vertical tower for hard drives in here. Yeah, I think it's got support for 8 by 1, 2, 3. I mean, it definitely supports more than that, but like I think it's got like mounting hardware for 8 drives out of the box. Although it's not like these are easily swappable if something dies. So here so all I'm doing here is I'm just randomly placing some holes for expansions. Oh, I already specified that. Basically for expansion's sake, if I want to, just say 20 millimeters, just for now. Cool. If we plump these holes down. Let me say I want to make pocket because there's nothing in the way. We'll just say parameters, tray, width. Oh, that didn't go all the way through. Enclosure width, not tray width. Did that wrong. No, pocket. Enclosure width. There we go. Yeah, so the idea for these is just they're for future expansion. Like if I want to, I would like to design a PCB that fits along the whole side of the back here. That basically, what do you call it? It's a back plane. That's what I'd like to do, but it's I don't have that designed right now, so I'm just gonna stick some mounting holes in here just so that if I design one in the future, I don't have to reprint this. And so now I think this is actually good for print. Or I mean, I think this is what I want. So now we need to think about how we're gonna actually print this thing, because it's a little awkward. Because if we print, realistically. You designed a PCB. That's what I want to do. I haven't done it yet. Sorry, that's what I want to do. You can find the connectors on DigiKey, right? What are these even called? SATA. I don't even know what to call these. Let's hard drive backplane or SATA. Sorry, SATA hard drive backplane connector. Backplane connector. I'm just trying to find a part number, is all. Basically this, but I'm going to make my own. Actually, SATA dual, triple drive. How many drives is this for? Oh, it's 2 drives. I want 3 drives. It says 3. Ooh, 3 drives. I mean, if I might re-engineer this to take one off-the-shelf one at some point, just so I don't have to do it. But the question is, I'm doing some funky stuff with the electrical in the rack. So, sorry. Let's see. Back plane. Oh, no worries, man. Yeah. No. Oh. Backplane connectors. Ooh. The question is whether I can find the one I'm looking for. Maybe specialized. SATA? Nope, I don't think this is what I'm looking for. This is some fancy connectors. Okay. I will have to figure out what these PCB non-stack through. Okay, look, they're in here somewhere. HTD. Nope. Okay, I will at some point. I will find that. Anyway, so I think this is probably pretty close to being good for print. So let's export this as an STL file. So we got. I'll just make a new folder, home lab, and save that. Bamboo. Oh right, I have the app image. Bamboo Studio. I don't care about updating. Prepare. Let's go to 3D modeling, STL, home lab. Bring in the enclosure. All right. Ooh, it's big. There's collisions with this zone, so we're gonna put. That's not the way we'd want to print it anyway. We'd want to do it face down. So we'll do that. Slice plate. How much has floating cantilever? Of course, because of these inside bits. And oh, I'm gonna have to. It's gonna be fun. Yeah, we'll have to find out. Yeah, 10 hours of printing with a 500 grams of plastic. That's... wow. Okay. Fun. So anyway, how do we want to... oh, that's with only 2 walls. Oh, geez. Slice plate. What if we did 3 walls? Oh, 630 grams of plastic. Okay. You need a whole spool. Little of... do I have that much PETG available on hand? I mean, I guess I'm going to have to run down to Micro Center. I built my own NAS using a 10-inch rack, custom design inserts, and a gutted NAS. Yeah. It's like, yeah, so let's see. 11 hours to print this model. Yeah, I mean, I figured. But, okay. Well, tool paths. Yeah, because it's basically solid all the way up through here. So, so if we were to say, you know, one of the things I'm kind of curious about is, so I said 2 wall loops. But what if I were to do, what if I print it with a bigger nozzle? Like, 10 hours to print. Yeah, it is kind of interesting that it only shaves off, does it really only shave off 30 minutes of print time? Yeah, it really only did. What if I did a whole 0.8? I do have these nozzles. So it'd be 850. So yeah, even if we went up to a big nozzle, it would still only save me an hour, a little over an hour. That's interesting. Oh, but I still defined 3 wall loop. Maybe if I go down to 2 wall loops, 8 hours 30. So maybe 2 hours, but that is kind of funny. Anywho, yeah, it would have saved me 2.5 hours. Okay, 8:30 instead of 11. Okay, I mean, that could be worth it. So yeah, floating cantilever, which means yeah, I mean we gotta add some supports. Otherwise, it's gonna explode in my face. So yeah, so we gotta go back to preview here. We're gonna say supports, enable. We're gonna say we're gonna use we're gonna use manual supports. On build, not on build plan only, but yeah, but we're gonna tell it where we want to put the supports essentially, and that's got to be this. Oh, sorry. We're gonna say paint the supports. We're gonna do a fill tool. This has to have supports. That's gonna need support. That's gonna need support. You know, another thing we can do here actually is that's gonna need support. These are gonna need supports. That. Alright, and we'll just leave... That will be fine, because that's printing between two towers, which means the print will go okay. Another thing that I could do here... Yeah, so I've got a P1S, so admittedly, yes, that's an expensive printer. Man, I started with an Ender 3 Mark II. Like that was it was a hand-me-down from a friend that got me into it, and then I had to, after a few years of using that, I was printing things so much that it was like, you know what? I'll get the good printer. But there's nothing wrong with an Ender 3. You can still make some really nice stuff on an Ender 3. Like, it's a workhorse. And actually, if you're still having bed leveling issues with it, one thing I recommend, maybe you do, but probably the best upgrade I ever did for it is called a BL Touch, which is a little touch sensor that you can mount on the Ender 3, and then you want to also install something called the Pro firmware, which is a community open source firmware, but there's a thing called a BL Touch. Yeah, you can see me searching stuff about my Ender 3 here. It's still not level, right? Ender 3. Yeah, there's a BL Touch, this little sensor. It's a distance sensor you can add, and then what you want to do is there's this thing called professional firmware, Ender 3 professional firmware mesh bed leveling. Trying to remember, yeah, Mr. Socks. Yeah, here we go. There's this thing called the Pro firmware, which is a open source, so it has nothing to do with Creality themselves. But somebody basically made a alternate firmware for the Ender 3 that you can just install by flashing it to an SD card. And it adds mesh leveling with the BL Touch, which means that as long as you have the bed mostly level, then it'll print fine, because it'll automatically adjust for the bed geometry. Yeah, so the BL Touch averages the height, but there's this thing called the professional firmware, which overrides the default firmware, and it will add mesh leveling to the printer. So it will measure as many points as you want on the bed. I used to have mine set at 81, and it measure a 9x9 grid, and then it would figure out the bed shape, and then use that to do the first layer on the print. So as long as you have the bed mostly level, it would print fine. And so I highly recommend this Pro firmware thing. I installed this on my Ender 3, and it made life so much better. Okay. Somebody is gonna be here soon. Okay, so now that we did this, I'm actually ending early tonight, just because I have some plans, which is why I started so early today. But really I'm trying to get back to being consistent about my stream time. It's just like I'm busy every night this week. Like I was doing this this was the plan for tonight, but then one of my friends wanted to meet up, and then tomorrow is a robotics club thing, and then Thursday I'm going to some robotics industry event. and then Friday is party. So this is the only other night I had things. But yeah, so if we slice the plate now, yeah, now we're at 13 hours because I got to print supports down here. But what we can do, one of the things I want, so so in the time that I have left here, one thing we can try to do to remove the amount of supports that we need is we can actually do we're gonna try, this is called a. Actually, I mean that I do want to start. That actually, what we can do is we can do what's called a ferrule or a chamfer, and what that'll let. Oh, damn it. No chamfer. 1.2. 1.9. It's gonna freak out at 2. Yeah. All right. 1.95? That's just a free CAD erroneous thing. But yeah, so we'll do chamfer, add edge, select, do that. Actually, that was not going to work. Do that one, that one. Basically, we're trying, one thing we can just try to do is remove overhangs. And a good way to do that is to add chamfers to the edges of things. So we'll do chamfers on those. That'll prevent the need for us to do supports on those particular columns, because when it prints, it's a 45-degree angle to the bed. So make life a little easier there. But this is going to absolutely need supports. There's no way to get around this part of it. So, but what we can do, we'll go back in here. We'll add the other stuff. So select. We'll see what adding this column does. Okay. Oh, cool. That chamfered up. Fine. Okay. We're gonna select some more edges. Select. Add edge. Add edge. Add edge. Add edge. Add edge. Add edge. Doop. Doop. Okay. Like that. Cool. And we're still going to have to do supports on the cross beams here. Daniel. So yeah, so we'll do chamfer here, chamfer here. We'll make this 3 mil chamfer. Oh, that didn't work. 2 mil chamfer. Yeah, there we go. A little bit of a design flair doing that one. Okay. Okay, do that. Alrighty. So another thing that we can try to do is, so we've got these here. One thing that I will try to do is if we essentially add some shape that connects it to the side, we can probably avoid needing to bring support column all the way up there. So that would be ideal. Okay. How are we going to get about that, though? There is a... It's probably a tool to do this. Anywho, because I have a friend showing up in mere moments. He said he's on his way. I'm going to call it here, but let's see what that saved us anyway on, at least with these little chamfering this stuff. So, if we re-export this, export, overwrite that, bring back this, reload from disk, 24 non-manifolded edges, because I need to erase all painting, and then refill reslice the plate. Okay, yeah, and that's just, sorry. Select that, select this. We gotta still talk about our supports, which will, in this now only needs to be this and these. And the other should just print correctly. So now if we slice the plate, we don't need to do those. It's still like 13-hour print, but it's a lot better than we were doing before. So yeah, I'm gonna call it here. Thank you all for this is the shortest stream yet, just because I ended up double booking. But let's see here. So thank you all for watching this tonight. I'm not. Let's see. I might, if anybody actually wants, I'll continue this. But considering like, I mean, people seem to really like to watch the robotic stuff. So we might actually next week start on. So based on the results of the poll, with its 2 votes, we'll do the robot operating system based robot with SLAM, where we're going to start building that, and we'll do the hardware. The thought was we'll do the hardware from scratch, as in I'll point a camera at me soldering things, and build the rest of the robot up. But okay, my friend just got here, so if anything, I will post an update on this at some point. But thank you all for watching, and hope you all have a good evening, or good afternoon, or good morning, or good day, depending on wherever in the world you are. So, alrighty.